This video, we're going to talk about some additional problems from 15.5, where we're going to solve radical equations by using the squaring property of equality, but we're going to use that property twice in these problems. So these are like problems from 15.5. I'm going to do problems like number 19 and number 41. I'm only going to do a few problems, two like number 19 and one like number 41. So again, we're going to watch out for extraneous solutions here, just like we did last time. The square root of x plus 2 equals the square root of x plus 16. Notice how this is different than the number 19 problem that I did in the first video, because we can't get one square root by itself on one side and everything that's not a square root on the other side. And we can't get just a square root on one side and just a square root on the other side. That plus 2 is going to mess us up. So we're going to end up having to square both sides, and we're going to get a middle term that has a square root in it. So when we square both sides here, and we have the square root of x times the square root of x is x. 2 times the square root of x and another 2 square root of x is 4 square root of x, plus 2 times 2 is 4. When I square this square root, I get x plus 16. Then I'm going to try and isolate this square root. I'm going to get everything that doesn't have a square root in it over to the other side of the equation. So when I subtract x to get it to the right-hand side, that just goes away. I subtract 4. That gives me 12. Divide by 4. And I get 3. And then when I square both sides again, this is where I'm using it the second time, I get 9. Let me check my answer. Square root of 9 plus 2, is that equal to the square root 9 plus 16? 3 plus 2, is that the same as the root 25? 5 is definitely equal to 5. So this is a good answer. We're going to do another one like that now. It's going to be square root of x plus 15 is equal to root x plus 1. All I did was switch stuff around, so the one with the extra piece was over on the right this time, and the single square root was on the left, but it's very much like the last problem that we did. So we're going to square both sides again. X plus 15 is equal to x plus 2 root x plus 1. Going to try and get everything away from this square root that's on the right. So subtract x's, subtract 1. 14 is equal to 2 root x. Divide by 2. 7 is equal to root x, and square both sides again to get the x equals 49. And we are going to check our answer. 49 plus 15, is that root 49 plus 1? So we do get a 64 on the inside here, and we get 7 plus 1 over here, and root 64 is equal to 8. So this is a good answer. All right. Now we have one more problem here, and that is root x plus 144 equals root x minus 12. And we again are going to square both sides. X plus 144 equals x minus 24x plus 144. Subtract 144 from both sides. subtract x from both sides, 0 equals negative 24x. And when I divide by negative 24, I get x is 0. So let's just check that out. See if that works. 0 plus 144, root 0 minus 12, root 144. Is that the same as 0 minus 12? Is 12 the same thing as negative 12? It is not, so there's no solution to this problem. The only solution that we got was an extraneous solution, so no solution. All right. That's it for 15.5. When we come back and do our next video, it will be some supplemental content. We're going to do problems like those from 9.9, but we're going to be talking about imaginary numbers. And so we'll be using some instructor created questions in the next several videos on our topics about imaginary or complex numbers. See you for the next videos.